So we're dealing with Pythagoras' theorem today. Okay, so let's go. So we have a right angle triangle. Everybody know what is a right angle triangle? It's a triangle in which one of the angle is a right angle, right? How many angles are there in a triangle, by the way? How many angles are there in a triangle? Three, right? Three angles in a triangle. So you have one up here, one down here, and then the right angle triangle. Well, the 90-degree angle, right? So notation of a triangle is very important when you're doing trigonometric ratios and Pythagoras' theorem, right? You see this capital B here? Your capital letters would represent your vertices, right? Some people say, like, when you say capital B here, you're also talking about this angle here. But the angle by capital B in reality is actually ABC, right? That is how you would write that angle. Write it A to B to C, okay? Right? So as I was saying, like, if we look at angle A to B to C, anytime you see that written anywhere, they are speaking about this angle up here, right? This is your angle A to B to C. Everybody clear there? That's how you state that angle. If you're talking about, now you can say CBA also, eh? C to B to A, but the B must be in the middle, right? Everybody good there? A in Jutram. You good there? Right. So, a right angle triangle is a triangle that has one angle exactly as 90 degrees. I already said that. Notation of a triangle, vertices are represented by capital letters. Opposite each capital letter is the side which is represented by the common letter. So understanding where your common letter is also very important. So you're seeing capital B here. None of the lines forming that angle could be common B. Are we clear? Common B would be the side opposite to capital B, right? Where would common C be? If capital C is here, common C will be the side opposite. No, this way. When I watch it here, is that way, but up there, opposite capital C. You all seen it? That will be common C. Okay? Everybody clear there? Common A will be opposite capital A, right? Notation of a triangle. Hey, bro, morning. Notation of a... That's okay, brother. That's okay. Right. So, we go now. The hypotenuse, the side opposite the right angle is called the hypotenuse, right? So we go now. The side opposite the right angle here will be common what? Let me see who following. The side that is opposite the right angle is common what? A. Proper, right? So common A in this case will be your hypotenuse. So this here will be my hypotenuse. Everybody good there? Common A is the side opposite to the right angle. Point to note, none of the sides forming my right angle could ever be your hypotenuse. It don't matter if the angle up here, none of the sides forming the right angle could ever be a hypotenuse. You hear me, Caitlin, saying that? None of the lines forming your right angle could ever be a hypotenuse. Your hypotenuse will always be the other side. So once you look at those two sides forming a right angle, you know your hypotenuse is the next side, right? So there we go. Right, so look, it's written here. The hypotenuse can never be one of the sides forming the 90-degree angle, right? Proper thing. Everything I say is right, you know. So Pythagoras' theorem applies to right-angled 90-degree triangles only, right? Now, some people write their theorems different, right? I see a lot of teachers now writing it like this. They put in C as a hypotenuse, right? But this is how I write mine. I put A squared is equal to B squared plus C squared, right? Where A is their hypotenuse. Everybody clear there? So, changing subject of the formula is everything. All you know this, right? So once you remember the main formula, and they want you to find like common B instead, it's just these sub formulas here, right? So your main formula is A squared is equal to B squared plus C squared, right, Brendan? That's the main formula. If you want to find a side, let me say common B, you carry capitals common C on this side, and what you do with it if you're adding it here, you're gonna minus it. So it'll be common B squared is equal to common A squared minus common C squared. Are we clear here? Talk to my hammer, you clear? Pythagoras theorem had to be clear after today, you know. I don't nobody not understanding this, you know. Talk to Mikhail.
You can scroll up a little bit so I can.
We have some Pythagoras theorem. Make sure you can identify the sides, right? So one side is 4, one side is 3, and the other side is x, right? Which side here would be my hypotenuse? X, right? Clear as day. So once you remember the base formula, which is a squared is equal to b squared plus c squared, right? A is your hypotenuse. So let's plug in stuff, right? What is A in this case? What is my hypotenuse in this case, then A? What is my hypotenuse there? You don't know? X, right? X squared, then A, we had a luckiness, sister. X squared is equal to, now B and C could be anyone. Anyhow you write it, it don't matter. If I put 4 squared plus 3 squared, is it the same as 3 squared plus 4 squared? Yes. So don't matter which one you put first, right? So let me go. I'm going to just put the 4 first, right? 4 squared plus 3 squared. Who lost? Because someone are looking lost. Alejandro, you understand what's going on here? Talk to me. 4 squared plus... Right.
16 plus 9.
Proper. 4 squared is 16, not 8, because I don't know how people watching 4 squared and thinking it's 8. 4 squared is 16. 3 squared is 9, right? Let me put that in the next line. 16 plus 9, x squared will be equal to 25. Now, we did this when we did algebra. I know there are good bit of children here that did not do algebra with me. You all will be able to do algebra when I'm doing the module 1 class, right? But in order to find the value of x here, we need to do the opposite of squared, which is square root on that side. Rishan, this must be looking like real food for you, right? So this is equal to the square root of 25. X would be equal to 5, right? I did not put a measure here like centimeters or anything yet because we ain't ready for that. I just want you all to understand it first, right? So they want you to find the length of the unknown side, okay? So which side here is the hypotenuse? That's the main thing. Could you identify the hypotenuse? Y, right? What is the formula for Pythagoras' theorem? A squared is equal to b squared plus c squared, right? Now, Pythagoras' theorem only applies to right angle triangles, right? Please stick that in your head somewhere. Pythagoras' theorem only applies to right angle triangles. So let's put it in here. This will be, what we put in here? Equals to A and B, anyone can be anyone.
4 squared plus 5 squared.
Proper. So y squared will be equal to, let's give me the final answer. 144 plus 25 is what?
169.
We do the opposite of squared here, which is square root. Square root of 169 would be?
13.
Everybody good there? Right? So this is how the questions are done in real life, right? Okay? So they said the diagram below, not drawn to scale, shows a ladder against a vertical wall. The foot of the ladder rests on horizontal ground. The wall is 12 meters high. And the foot of the ladder is 16 meters from the wall, right? So, what are they asking us? They're asking us to find the length of the ladder. I put on it there that you could use hypotenuse, Pythagoras' theorem as a hint. I'll give you that as a hint, right? So let me go. Simple thing, just like what we were doing above, right? So what is Pythagoras' theorem? Remind me? What is Pythagoras' theorem? What's the formula?
A squared plus equals to b squared plus c squared.
Right. So let's work. What will be A here? A will be the ladder, right? So let's put L. So let's put L. L squared is equal to B and C could be 16 or 12, vice versa, it doesn't matter, right? So 16 squared plus 12 squared, right? So L squared will be equal to the square root, well, give me the answer here first. Somebody tell. So L squared will be equal to 400. So L would be equal to the square root of 400. L will be equal to what? 20. Right? 20 meters. Points to note. Your hypotenuse will always be your longest side. Right? It will always be your longest side. So, This is the notation of a triangle, right? You have capital A, capital B, capital C, and all your commons, right? Now, within this triangle, you have angles, right? We're going to call this angle theta, right? This symbol is theta. Everybody good there? Now, they want me to find theta. So in order to find theta, we apply one of the trigonometric ratios, right? What are my trigonometric ratios? They are, I call them so, ka, toa, right? Okay? Right? So you'll remember. So before I even jump into SOCA toa, let's see if we could identify some things here. And y'all told me that this length here is my hypotenuse, right? Let me use a different color. Here is my hypotenuse. Everybody agrees? Yeah. Right? Now, with respect to theta, which side here would be my opposite side? Let me see who remembers someone I did it last time. C.
Common C.
Common C, proper. Why is it opposite? Because it is opposite the angle theta, right? So this here would be my opposite. So I tell students, once they could identify hypotenuse and they could identify your opposite, adjacent would just be the next side, right? Adjacent means next to, right? So this is adjacent. Okay? Why? Because it is next to. But you have to be able to identify your hypotenuse, your opposite, and the next side will just be my adjacent. So let me look at the trigonometric ratios now. Now you must have a calculator for this part of our class. Must. If you don't have a calculator, go and get one. So, how do we write so? Sine of the angle theta is equal to the O stands for what? Opposite over hypotenuse. Ooh. Opposite over hypotenuse, right? Then ka, the C stands for cosine, right? Well, we'll just write cos. Cos of the angle theta would be equal to, what does the A stand for, my children?
Adjacent.
Adjacent over, H stands for hypotenuse. Then toa, the T is for tan. Tan of theta is equal to opposite, O is the opposite, over A is for adjacent. Right? I'm hoping that this is looking very. So we're going to find theta. So let's identify some things, right? We're dealing with our ladder. Did we just find here to be 20 meters? Yes. So which side is my hypotenuse?
The ladder.
The ladder. Which side is my opposite?
Wall.
Right? Opposite. And which side is my adjacent? 60.
The vertical wall. Well,
No, not the vertical wall. Adjacent. Once you can identify hypotenuse, or listen to me, don't tie this thing up, right? Once you can identify a hypotenuse, you can identify your opposite. The other side. There's only 3 sides in that triangle. Right? Like, we don't complicate the thing. There's only 3 sides in that triangle. Identify your opposite, identify your hypotenuse. Right, just write the next one as adjacent, right? So let me go. This is how we do this thing, right? Now you want to find theta. In this case, because we want to find theta, not one of these sides, you could actually use any one of the trigonometric ratios, right? I will just rule it sine. Okay? So sine of theta would be equal to opposite over hypotenuse, right? Your opposite side here is what? What is my opposite side? Sometimes I ask you all the most trivial questions just to make sure you're following, right? Very good. So sine of theta, which is unknown, would be equal to my opposite, which is 12, over my hypotenuse, which is 20. Now, in this case, we want to find theta. So only when we need to find theta, which is the angle, you carry sine. Sine is moving by itself over here, right? So theta, watch it here, Hamid. Theta will be equal to the opposite of sine, which is sine -1, the inverse of sine. Only when sine is moving by itself, it changes to the inverse of sine. If I was moving sine theta somewhere, it remains sine. Right, Hamid and Narayan? Only if I was moving sine theta, it would remain as sine theta. If I'm moving sine by itself, it becomes sine inverse, right? So watch this. This will be 12 over 20. So on your calculator, because I'm sure there are people who don't know how to activate this sine negative one, right? On your calculator, you will have to press the second function button, right? On some calculators, I think it is shift. You're pressing the shift button followed by the sine button. Say that again, bro. Go to 2. Right? Yeah, go ahead now. So if this side is your calculator screen here, my brothers and sisters, you must be seeing D, E, G above in some calculators.
0.6.
In some calculators, it would be D, E, G. It might just be at D. Make sure it is on D or D, E, G. In order to access that, you'll see a knob mark D, R, G. Press D, R, G until you see D, E, G above. Your calculator must be in degrees. Are we clear? Right? These are the little intricate things you need to know when doing sine and cosine. Your calculator must be in degrees, right? So there we go. So theta would be equal to, I need you to put sine negative 1 open bracket 12 over 20 close the bracket. Press equal and tell me what you'll get in there. I see somebody put 36.1. 36.
36.8.
36.8, right? What after the 8? 7. Right? So this will be what? Because it's an angle, what would it be? Degrees.
Degrees.
Proper. Right? 36.87 degrees. So the diagram below, not drawn to scale, shows two straight wires, L, G, and N, K. L to G and N to K, supporting a vertical pole, right? Your vertical pole will be this pole in the middle here, right? Which is GM or MG. You have it as MG. L, M, N, L to M to N is a straight line. Okay, you're seeing as a straight line there on the horizontal plane. Angle JML is 90. So JML is 90. They already have that written in, right? Then angle KNM, K to N to M. Point to note, you see the middle letter, this letter here, would always be where the angle is located, right? So this here is 30 degrees. And then they said LJ is 13, LM is 5, and KN is 10. What is W doing in front here? Hold on, I don't know what I'm doing there. Calculate in meters the length of MK, right? Now, at this point in time, you need to be able to separate the triangles, right? Separate the triangles in your head, right? So let me ask some questions. We're dealing with the triangle on the right, okay? Look at the triangle on the right. First things first. If this LMN is a straight line and this side is 90, what would be the next side? Anybody knows? What on this side would be? 90.
90.
Why is that 90? Because the angles at a point on a straight line must add up to 180 degrees. And you take it once it's a vertical pole, it means this side is 90, the next side is 90. Right? Everybody good there? So I need you all to cipher this in my head. Usually I just highlight the triangle we're working on. But I need you all to highlight it in your brain. Right? Focus on the angle with vertices N to K to M. Everybody good there? Michael lucky, né? N to K to M. Which side would be my hypotenuse? 10.
K.
No. K represents this point here. K represents, capital K represents this point. If you had to call it a common letter, what it would be? Common what? M. Because capital M is here, common M would be here. Right? Now, if you could see that, half the battle already won with Pythagoras' theorem and trigonometric ratios. Right? Once you could identify that this is your hypotenuse, this side here is your hypotenuse, and you could also identify that this is common M, half the battle is already won. So let's focus. Which side would be my opposite?
Common N.
Common N. Excellent. Which is also, you can also use capital MK, which is what they're asking for. Right? That would be the side opposite. So let us stay with me here. This is your opposite side, M to K. Let me highlight that line. This is the line that they want us to find. Okay? Everybody seen that? It's your opposite side. Let me put OPP because I want a little soak this in. OPP. Cool? Now, focus. We're not gonna highlight the adjacent side. Let me tell you all why. We want your opposite side. We were given the hypotenuse. So that tells us which one of the three trigonometric ratios that we would need to use, right? Which one of the three ratios uses opposite and hypotenuse? Sine, right? So let me make some space here. So we're using sine to find MK. So this is how you line it up, right? Let's write the formula. Sine of theta, which is your angle, is equal to your opposite over your hypotenuse. Stay with me, all right? All right? All the people who never did it before, stay with me. Take your time, compose yourself. It'll be sine of, look at the triangle we're focusing on. What is the angle that is given in that triangle there? 30. So instead of putting theta, I'm going to put 30. You see that there, Micah? Proper, right? Micah, what could we call our opposite side? What are the two vertices that form an opposite side? I want to make sure you understand where I'm going. Put MK, okay? So I'm going to put MK because that is my hypotenuse. No problem, Malachi. Okay? And MK is what we're asking for. Look at it. Over, Nikosi, what's my hypotenuse here? 10. To do here next, right? You want to find MK, you had to move that 10, right? So the 10 moves here and multiplies. Now the thing about this, we're going to put the 10 in front of the sine 30, right? So watch it here. This will be 10 multiplied by sine of 30 is equal to MK. You proceed to your calculator, you punch that in and tell me what you are getting there. 5 straight 5? So this will be 5 what? What is the measure? 5 meters is equal to MK. Talk to me, right? We want to find M to N next, right? Focus. M to N. So, did we now find this line here? Watch it, this thing had a plug back in. Right. Did we just find this opposite side? What did we just find this side to be?
5.
5, right?
5.
Now, the question wants us to find MN, right? Somebody tell me what we need to do there. Who did it already? Because I didn't do any questions like this yet. That was a question I think Varun asked, right? What is MN here?
Adjacent.
It is the adjacent side. Now, we can't use the trigonometric ratios, right? But I'm going to use the Pythagoras theorem, right? I'm going to use Pythagoras theorem. So, let's focus on this again, right? What is my hypotenuse? My hypotenuse is how much meters? 10. And then the other side in the triangle is how much? 5? Right. So, this is a side we want to find. So, when you want to find a side that is not your hypotenuse, you would say b squared is equal to a squared, which represents the hypotenuse minus the other side that was given squared. Right? Cool? So in this case, what is the side we want to find here? What is the side we want to find in this case? MN. We could call it capital M, capital N, right? That is this side here. You seen it here, Micah? M to N is here. Right, bro? MN. So, I'm going to put MN squared is equal to, what is A? A represents my hypotenuse. What is my hypotenuse in the triangle on the right? Focus on the triangle on the right. What is it? 10. Everybody with me? 10. Right? Nikosi, talk to me. Minus, not plus, minus. Once you're trying to find a side, you are minusing, my children. Now, C would be the side that was given, right? So, what is the other side in this triangle here that was given? 5. Proper. So, everybody good here? So, this will be 5 squared, right? So mn would be equal to, I kindly squared on the other side one time. We need to find the square root of what you get when you work out this. Where you get when you work out this? Somebody give me 75. So you have to go to two decimal places, right? So mn would be equal to the square root of 75, which is 8.6. What? 66. What after that 6? 0, right? So 8.66, and this was what? Meters? Meters. Everybody here? Right, so that part done. Let's see what they're asking us next, right? They want J key, right? Let me make a little space here. They want J key next. So let's go up. So what you could do when you're doing this in CXC, right? Wherever you find you put it in, because sometimes it would help you for the next part. And we just found here, what here was? 8.66 meters, right? So we want JK now. You all see what JK is? We want this piece. Let me hear your ideas. I want some ideas. Go ahead. Hey, this is how the questions going to come, eh? You need to find JM first. You saw that, Brendan? You didn't see that? You need to find JM first, which is this full line here, right? Then when I find JM, I can minus 5 from it, and I'll remain with JK. So JM could be found by using Pythagoras' theorem on the left-hand side triangle. You all see that? Pythagoras' theorem. So there we go. We're trying to find our side, not the hypotenuse. What is the hypotenuse in the triangle on the left-hand side? What is the hypotenuse there? 13, right?
13 meters.
We functioning. We functioning right now. So we're using the edited version of Pythagoras' theorem, right? So we're going to change the subject of the formula, in other words, and we're going to make b. We could just use b. So common b squared is equal to the hypotenuse squared minus the other side squared, right? So common b in this case will be what we are trying to find, right? But it's not jk yet. Remind me again what we're trying to find first? JM proper. That means people following. People are following, right? So JM squared is equal to, who remember what the hypotenuse was?
13 meters.
Minus the other side was 5, are you sure?
Yes, sir.
So JM would be equal to, hey, that's a point to note. This 5 is not this 5 here. That is this 5 we're talking about. Everybody clear there? This 5 is the 5 we're talking about. We're looking at the peripheral lines of this triangle. Okay? This 5 we're using it, but we're using it to minus it from wherever we get so that we can find JK. Right? So we go back now. So Hitman, JM will be equal to the square root of what?
144.
144 flat? 194?
144.
144, you had a minus, correct?
144.
Yeah, you had a minus, bro. Right?
169 minus 25.
Right. So that would be 12, right? 12 meters is JM. So straight one time I'm gonna jump into it. Therefore, JK will be equal to 12 minus what? 5.
5.
Which is,
7.
look how we working that way. Right, so we're gonna find angle JLM. Where would this angle be located by? Which one of these letters? The J, the L, or the M? L. So we're going straight by L when we go up here, right? J to L to M would be right here. Boom. So let me call it theta. So we want to find theta. So you'll realize we have all the sides here because we found up here what we found here to be, what JK was? 7.
7.
Right? So we had this full length here, which is 13, 12. Right? We could use any one of the ratios. Right? When you want to find theta and you have all 3 sides in the triangle, you could use any one of the ratios, right? I just go and use sine, right? Which will be opposite, which is 12. The full length is 12 over the hypotenuse 13, right? So we're going to... Yes, go ahead.
Can I use the washroom real quick?
Yes, sure, no problem. So sine of theta is equal to opposite over hypotenuse, right? So sine of theta, which is unknown, theta is unknown, would be opposite. Going back up to shoulder, your opposite side would be the full 12. It will be from here to here, which is 12 meters. Okay? Cool? The full length is 12. So your opposite would be the 12. Everybody clear there? That is the opposite length is this. So let's see how much times I've shown it and how much different ways I've shown it, right? This is your opposite line, the red line here. 12 meters. So opposite is 12. Hypotenuse is cool. So let me work. Right? So this will be 12 over 13, right? 12 over 13. So what we doing here? We want to find theta. So what we moving? Changing subject of the formula. What we moving? Sine. Sine moving by itself without theta. Once sine is moving by itself without theta, what do we do? Sine.
Inverse sine.
Inverse of sine. Sine -1 of 12 over 13, which will give me what, my children?
67.38.
67.38, and it's an angle, so it would be degrees. If? Right, so let me deal with this question here. January 2010, right? The diagram below shows a triangle LMN with LN as 12, NM as X, and angle NLM as theta. The point K on LM is such that NK is perpendicular. So you all saw this word being thrown around here. What does perpendicular mean? Anybody knows? When they meet, they form a 90-degree angle, a right angle, right? So if two lines are perpendicular, it means where they meet, they said LM, which is this line here, is perpendicular to N. Well, NK, sorry, is perpendicular to LM, meaning that where NK meets LM, it forms a 90-degree triangle, right? Okay? NK is equal to 6 and KM is equal to 8. Right? That's all the information we were given. The question came and asked us to find the value of X and find the value of theta. Right? So let's look. We're dealing with X first because that's the obvious, easiest question to do there. So if you focus on this triangle, boom, bang, bang, bang. Caitlin Sinanan, which side here is my hypotenuse?
The hypotenuse will be X centimeters.
Right. X is the hypotenuse. Once you can identify that, you can proceed to find your answer. So let me work. What's the formula I gave you all? Now, guys, if you all ever seen CSEC, anytime they use like C squared is equal to A squared plus B squared, it's the same thing, eh? It's just that CSEC using C as their hypotenuse. So I can even use that formula here. But just C is my hypotenuse. From the time you see minus in the middle here, it means that whatever is on this side is not a hypotenuse. Alright? So C is the hypotenuse in this. So let me work it like this. So if I want to find X, right? This is part 1. Instead of C, what do I put? What is the hypotenuse here? That's why I don't want to let it stick on the A. So this will be X squared is equal to A and B in this case would be what? 6 or 8, it don't matter the order I put it, right? 6 squared plus 8 squared. X would be equal to the square root of what? 100? 6 6s are 36 plus 8 8s are 64. 36 plus 64 would be equal to the square root of
10 centimeters.
square root of 100, which is 10 centimeters. Everybody good there? Who is lost? Don't get tapped with these formulas, please. If I write it like this, just understand, right? B squared plus C squared, right? Just understand that in this formula, they use C as their hypotenuse. In this formula, I use A as my hypotenuse. Are we clear? So let me work with theta, right? Theta, focus on the triangle on the left, right? Micah, which side here is my hypotenuse? How much centimeters is my hypotenuse for the triangle on the left, Micah? Is it going to be 6 or is it going to be 12? 12, right? Now, point to note, is this a right angle here, Rishana? On this side also, right? Because this line and this line are perpendicular, so on both sides we would have right angles, right? So, your hypotenuse could never be any of these sides forming my right angle, okay? Mr. Alejandro, with respect to this angle here, theta, which side would be my, he said, Micah said this is my hypotenuse, right? Which side here would be my opposite? Which one?
So the side with 6.
Capital L. Yes, somebody online said it, right? The side with 6. 6 is your opposite. Watch, that is my opposite. Common L, if you want to call it that. This is common L, right? It is also NK. Are we clear? So, if I only have, they gave us my opposite, our opposite, they gave us our hypotenuse and they want us to find theta. So, in this case, you have to use the information you were given. Which formula uses opposite and hypotenuse? Sine. Not cos, brother. So, ka, right? Toa. Write it down if you need to write it down. Right, my children? Write it down if you need to write it down. That first one, opposite and hypotenuse. Adjacent and hypotenuse. Opposite and adjacent. Right? That's solid. Could never go wrong with that. Right? So there we go. We're using the one that has opposite and hypotenuse, right? So that'll be sine theta is equal to opposite over hypotenuse, right? So from the question above, sine theta would be equal to what is my opposite? 6. What is my hypotenuse? 12, right? 6 and 12, right? Nikosi, why do you know the sign when I carry it here, Nikosi? So to be sine inverse of 6 over 12, right? Punch that in on a calculator, and what are you getting there, Denny? How much? 30 flat?
Yes, sir, 30 degrees.
30 degrees flat. Right, so the first thing they wanted us to find was LK. Right, LK. What we use there? Pythagoras' theorem? We want this side. Pythagoras' theorem. What do we want to find? A side or the hypotenuse? Now, if you use a different route, no problem, because you could have used a different route. But what this side would be? A side or my hypotenuse? This LK. A side. So that side is going to be equal to the hypotenuse squared minus the other side squared. Now I'm working with this formula here, which is what I use. I'm working with this formula. Okay? This is the one I used. C was my hypotenuse. So I showed already variations in the formulas, right? So we go in. If I want to find a side, in this case, if I want to find B, right? In this case, B squared will be equal to C squared, which is represented my hypotenuse for that formula I wrote above, minus the other side squared, which is A squared, right? Please do not get confused with this. Just know which one is the hypotenuse. So let me go. In this case, common B would be LK. Everybody good there? LK squared is equal to what was my hypotenuse in that part of the triangle? Huh?
I think 12, sir.
Minus, if you're thinking and write it down, crew. What A was? The next side. 6 squared. So LK would be equal to the square root of 108. Right. So LK would be 10.4.
10.2, right?
10.39. If you have 10.4, no problem, right? 10.39 centimeters. Right.
Yes, sir.
Let me hit angle NMK one time, right? N to M to K. Where we are? N to M to K is here. Right? So this, let me call this theta. Right? Even though they have a next theta on the side, right? We call it theta for this question also, right? So let me go. What you'll use? Sine, opposite. Right? Opposite and hypotenuse, right? So this is your opposite. This is your height. Okay, so remember 6 and 10. We're going down. So sine of theta is equal to opposite over hypotenuse. Sine of theta would be equal to 6 over 10, right? Bring the sine alone here. When you move sine by itself, what do we do? Inverse. So theta is equal to sine -1 of 6 over 10. Theta is equal to 71?
6.87 degrees.
87.
Yeah.
That correct? Right. Right. The diagram below shows an equilateral triangle FGH, whose base is 13 centimeters, right? And its height is h. Now, something about this, if it's an equilateral triangle, here will be 13 and here will be 13 centimeters, right? Calculate the value of h. Did you all realize that these are two identical triangles within this big triangle here? Huh? Yes, it is. So this line actually is the midpoint here. So if this is the midpoint, what will be the base on this side for this triangle on this side? How much? What will be the length from F? Let me call here M. What will be the length from F to M? 6.5 on this side and 6.5 on this side. Cool? Right? So let's work with one triangle. Let's work with this triangle on this side here. So we work with this bad boy here, right? Boom, bang, bang, bang. Right? We work with this bad boy here, right? Right? I don't really have it precise there, but I'll get the idea. So for that triangle there, what do we want to find? The hypotenuse or a side? A side. Any one of the formulas you want to use, you could use, guys. I just stick to a squared is equal to b squared plus c squared. That's what I stick to. You'll actually see a question below here. You'll see they have the hypotenuse as c. You'll see that? So I just don't want you all to get tied up when you're doing that, right? So there we go. A squared is equal to b squared plus c squared. What is my hypotenuse in this question? It's a, right? So the edited version of this formula would be b squared is equal to your hypotenuse squared minus your other side squared. Everybody good there? All right. So there we go. What is my common b in this case? My common b would be what we're trying to find, which is represented by what we're trying to find there. Somebody's seen it. H. H squared will be equal to what is my hypotenuse?
15.
What is C, the other side? So H would be equal to the square root of what? 1 who? 126 point. Right? And the square root of that will be, what is the value of H? 11.26 or 11.26 or 3, right? Centimeters. 11.3. Okay? Centimeters, right? CXC's standard is like three significant figures to these kind of questions, right? So like even if you have like a single whole number, you put two decimal places. If you have like 11 here, which is 2 digits, you put one decimal place. It's three significant figures, right? So there we go. But if you put 11.26, you're still getting it right. 11.3, you'll get it correct. Right? So find the angle HGF. So H to G to F would be this bad boy here. I read that wrong? HFG. Sorry. HFG. So it's the same thing. They want this angle on the side, which is the same thing here. But what that angle would be? This was an equilateral triangle. This was an equilateral triangle. I hope you see that all. They didn't go and do no sine rule and cosine rule and all that bacchanal, eh? Was the if it's an equilateral triangle, what angle will be? Huh? 60? So HFG, the triangles of a triangle, will be equal to 180 divided by 3, which will be 60 degrees. Uh-huh. It is an equilateral triangle earlier. This side is equal to this side, which is equal to this side, right? And here would be 90 degrees too, eh? Right? Class. Right, so a vertical flagpole FP stands on horizontal ground and is held by two ropes, right? These are the ropes here, boom, bang. PG and PR, as shown in the diagram below. PG is 18, FR is 9.7 meters. And flag FPG is equal to 38, right? I'm sorry, angle Angle FPG is equal to 38. That's here. Calculate the height of the flagpole FP. Come on, what are you use? Let me hear you. Talk up. What are we using here?
A squared plus B squared equals C squared.
No. We can't use that.
Then multiply by hypotenuse.
Side multiply by hypotenuse, Abraham, that's what I say. Okay? So the rationale here would be that you have your hypotenuse, which is 18, and you want to find your flagpole, which is your opposite, right? So I worked with this triangle here because it had more information as opposed to this triangle. This one only had 9.7. It wasn't enough to work with, right? So let me go. We're using sine as I said. So, okay? So sine of the angle theta is equal to opposite over hypotenuse. Sine of theta is equal to opposite is what? What can I represent opposite by, Micah? This is why I asked this since early. What I can represent opposite by? Huh? Common G proper, yeah, you could use that, but let me use capital FP, which is what they're asking for. Common G can be used, but you can use FP, capital FP. I'll use what they use, what CXC use, right? So it would be FP. You see where I get the FP from, right, Micah? F here to P. Cool? FP. So it would be FP, right? FP over your hypotenuse, which is 18. 18, right? Wait, I could put him a theta here and I realize I didn't put him a theta. What is theta? What is the angle? 38. What? I bring this here and I do exactly what Abraham was saying, right? I'm multiplying your hypotenuse, which is 18, multiplied by sine 38 is equal to FP. What will FP be? 11.08, and this would be meters. Everybody good there? See if y'all can articulate what's going on here. You don't have anything to work on. Is there something you have to think? Like a puzzle. Read it and see if you can figure out anything what's going on here. You're not using any numbers for this question. And I will make it real cool. The diagram below shows a right angle triangle with sides A units, B units, C units, right? Using the diagram, express C in terms of A. This is food. Express C in terms of A, right? So, what is the original formula using what they have here? What is the hypotenuse? Hypotenuse is what? C. C squared will be equal to B squared plus A squared, right? Or A squared plus B squared, however you want to write it, right? Now, express C in terms of A and B means you need to make C the subject, right? What do you do with the square when you carry it here? So C would actually be equal to the square root of B squared plus A. Let me put A squared plus B squared. I find that look a little neater. Alright? I don't know, them things that's mess with my mental. A squared plus B squared, right? Right, B squared. Everybody good there? C is the subject. If I say to express C, you cannot leave it as C squared is equal to A squared plus B squared. You won't get a mark. Express C means they want you to make C the subject, right? Now they say to write in terms of A and B an expression for sine theta plus cos theta. Now you all know sine theta would be equal to opposite over hypotenuse plus cos theta would be adjacent over hypotenuse. That what makes this question so cool, right? What is your opposite here? What letter represents my opposite here? A. Everybody seen that? A. And what will be my hypotenuse?
Come on, see.
Right? And what will ultimately be my adjacent?
B and C.
B and C.
I mean B, sir.
B, right? So this is what we're using. So opposite over hypotenuse will be A over C. Everybody agrees? A over C. Proper. Right? Plus, what is my adjacent? B over C. Right? So if a question like this come, all know all eating it up. Wait, what going there? Right? B over C. Now if my two denominators are the same, what I can do with my numerators? Right? So C would simply be underneath here and you'll have A plus B on top. Everybody good there?
Yes, sir.
Proper. Real easy, eh? And I never think it's so easy. Everybody good there? The last part is saying that theta, I'm using the result from part 1, A and B, right? Part 1, right, A and B here. Show that sine theta squared is equal to cos theta squared. Sorry, sine theta squared plus cos theta squared is equal to 1, right? So what's something here? And we had sine theta as, what sine theta was? Sine theta will be A over C.
A over C.
So I can put A over C squared plus B over C. Is B for the next one, eh? Right? B over C for cos squared is equal to, now we're trying to get 1, right? So this will be A squared over C squared plus B squared over C squared, right? Cool? Because this squared applies to both numerator and denominator. Now this would be A squared plus B squared all over C squared. Because it's the same denominator. But from part 1, what C squared was equal to? Look at right there. C squared is equal to A. Look at there. C squared is equal to A squared plus B squared. So watch. I could do either two things. It's either replace A squared plus B squared with C, or replace C with A squared plus B squared. I'll just say when, I'm going to put right here. When C squared is equal to A squared plus B squared, I can simply come down here now and put C squared over C squared. C squared divided by C squared will be equal to 1. So done. Trigonometry, right? So this question was in January 2028. It's a past paper question. These questions you have to think, right? So this is a cuboid. Everybody seen the cuboid? So the diagram is a cuboid. So even though it is slanted, see it as a straight box, right? See it as a box, right? Eden Jutram. Now, give your answer correct to 1 decimal place. So wherever we work out now, we do it to 1 decimal place. So they said a straight adjustable wire connects R to P along the top of the cuboid. Calculate the length of the wire RP. So R is here, right? Alright, that's let me get blue. Right. So R is up here. Everybody seen R? Right. Everybody seen P? Theta, Hamid. If I have a wire and I pull a wire from here, right. I pull a wire from here to here. What I need you all to visualize is on top there we have a rectangle. On top that box we have a rectangle. Once I bust a line in the middle there, Denny, what I split that rectangle into? 2 triangles, but 2 what kind of triangles specifically? Right angled triangles. Right angled triangles that I could apply Pythagoras' theorem to. I can apply all my trigonometric ratios to. SOHCAHTOA. Right? Okay? Everybody good there? That is what could happen there. So let me look. RP is what they want us to find. Now, let's examine some facts, right? We want RP. I put in a kind of, this is a right angle in the corner here. Everybody agrees? That is a right angle on top there. Okay? Now, this length here will be what? The length R to S will be how much centimeters? Everybody seen that? 100. Eden Jutram, you seen that here is 100 centimeters? Right. That done. Now, this base here in the triangle, P to S will be how much centimeters? Once you could see that, you conquer a lot. Everybody seen that? Right? You conquer a lot. So I have a right angle triangle. I have 2 sides. What is missing in that right angle triangle? The what? Come on. We're winning right now. Right? The hypotenuse is winning. Right? So let me go. Hypotenuse. What are we using? What theorem? Pythagoras' theorem, right? So Pythagoras' theorem would be A squared is equal to B squared plus C squared, right? So A squared being the hypotenuse, I'll just call that RP squared, right? So I'll have RP squared is equal to B and C, 100 or 60, doesn't matter, right? So I put 100 squared plus 60 squared, RP would be equal to the square root of what? 1300? 13,600, right? And the square root of that, look what the question said, eh? Hit me to one decimal, please. 116.6 centimeters, right? So I remove the word hypotenuse and I'm going to put 116.6 centimeters, right? So let's go. So the next part is saying the connection of P is, what's the scene morning? The connection of P is now adjusted and moved to T, right? So it means like it's on, I'm going up, it's on R to P, right? But they said they move the connection from P, they move this connection and they drop it to T, right? They move the connection and they drop it to T. So let me just clear up some things here, right? I'm moving this, right, just to see it a little better, right? I'm leaving this here, but here what I'm going to do, I'm going to pull back a line from R to P. But this is the line we really drop, right? I'm pulling back this line, boom. That line is 116. Now, if I drop that line, right, they say calculate the length of RT. You move the connection from P, so it's like you disconnect the wire and you drop it to T, right? You move that wire to T. Calculate the length of the wire RT. Now, are you seeing that R to P to T back to R is a right angle triangle? You seen that? It's another right angle triangle. And where would the right angle be? The right angle will be right here. Tell me if you're not seeing that now. Talk to me. Right? So the right angle includes this line here. Boom. Right? And it includes the diagonal here. I'm going to put back the diagonal in red. You've seen it there. You've seen it clear there. You've seen a right angle triangle. Right? So we have 116. Right? What else do we have here? Let me hear you all. This question was like a whole Pythagoras theorem question. We have 116, which is one side. What else do we have here, Aiden Jutram? Concentrate here, Aiden Jutram. What else do we have here? We have the 116, which is this line. What else do we have?
So you have the P and T is 20 cm.
Excellent, Augustus. I'm sorry, that's Abraham. All right? Come in. Right? Hi, morning. You had message, man? Yeah, all right, cool. Right. So, P to T is 20. All right? Everybody good there? Come in. Like I gotta bring out the next table, boy. Class start again. So, we have 116, 116.6, and we have 20. Cool? Now, what is missing? The what? What is missing?
Hypotenuse.
Hypotenuse. Everybody seen that? Can you all find my hypotenuse, please? Come on. So let's write out Pythagoras' theorem and solve, right? So I'm just going to put a squared is equal to b squared plus c squared. Remember, a is your hypotenuse in this case. So RT is my hypotenuse. This will be equal to 116.6 squared plus 20 squared. RT will be equal to the square root of what? 0.56. Leave 56 here. We'll write the answer to one decimal place, right? And what will my answer be to one decimal place? 118.3 centimeters. Proper angle. Calculate the angle TRV. T to R to V. We talking about which angle? Are we talking about this angle here? Huh? So what's something? Here we're going to do it. T to R to V is this angle up here. Here what I can do, I can actually drop this line down here. Why not drop it? Alright, we'll leave him there. I'll go down and draw our next line underneath here, right? Boom. Right. Watch this angle here. Okay? I'm going to delete this red line. You'll see the blue line underneath. Boom. And then I'll draw another blue line here. Boom. Are you all seeing that triangle there? T to R to V. Right? You all see that triangle? What kind of triangle is? It's a next right angle triangle. Where the right angle will be? Would it be up here or would it be down here?
By V.
By V, proper. By V, right? That is where my right angle will be. So let me examine this thing, right? What sides do we have in this triangle? We have all the sides. Because you have here's 20 centimeters, and this line at the base here is how much? The distance from here to here is what? From V to T. 116.6 proper. 116.6 centimeters. That's the same line above there, Ahmed. You know, you could see it there. You see that PR is the same as TV, right? So we actually have all the sides. So any one of the trigonometric ratios you want to use, you'll get the same answer, right? I like to use sine all the time. Sine, right? So we're going opposite over hypotenuse, right? So opposite will be 116 over, wait, something wrong here. This is 100. This is not 100. Where hypotenuse was 118. We just look at that. This is not the hypotenuse. This was the line on top here. This hypotenuse was what? We just look it out.
118.3.
118.3 centimeters would be my hypotenuse, right? So we could use opposite and hypotenuse, we could use adjacent and hypotenuse, we could use opposite and adjacent, wherever you want to use, right? So let me go. I gonna use sine, because I just like sine. Sine of the angle is equal to what? Over, let me plug in stuff, right? So that'll be sine of TRV, because TRV is the angle, right, Francis? So let me go. My opposite was what again? Was 116.6, right? Guys, please note that when I say opposite, if the angle is up here, the opposite side could never be one of the sides forming the angle. You hear me, Micah? It could never be one of these sides forming the angle. So it could never be TR and it could never be RV. It could never be, your opposite side could never be TR and it could never be RV. Your opposite side will be the side that is opposite the angle, right? So that opposite side will be this. That's where I got the 116 from. Everybody clear? And my hypotenuse would be 118.3. Right? So this will be over 118.3. What do? I need to move sine by itself. When sine is moving without the angle, what do we do to the sine? Let me hear a little. Sine inverse. Come on, man. Come on. So TRV is equal to sine -1 of 116.6 all over 118.3. Talk done. Right? Hit me there, Zaria. Remember one decimal place, right? 18.3. Somebody second this. 80. 80.3. Remember to put these bad boys in brackets, 80.3, and this is an angle, so it would be degrees. Alim Abraham, remember we going to one decimal place, right? So it'll be 80.3, right, bro?
Excuse me.
Complete the following statement. The size of the angle through which the wire moves from RP, I think RP was up here, RP to RT is what? RP to RT. So you move from RP down to RT. That angle is the movement here. Boom. This movement here. Anybody have any ideas how to find this angle up here? What do you think we could use there, Brendan? It's easier than you think. Recording. So this angle up here, which is P to R to V, is 90 degrees, right? Boom, bang. It's 90 degrees. So that 90-degree angle includes the angle we just found plus this green angle here, right? That's this angle here. So how do we get this angle? It will simply be 90 minus, what do we find this one to be? So let me do that, right? 90 minus 80.3, which will give me what by? So this will be 90 minus 80.3, which will give me 9 point degrees. An angle which is the same as RTV. An angle which is the same as R to T to V, right? What is an angle that is the same as R to T to V is this green angle that I put initially. But this green angle will be the same as which angle? You are saying it. The angle we just found, right? Because they are what type of angles? Same 9.7, right? But they ask which angle is the same as RTV. The answer would be PRT, right? PRT is the same as RTV. Why are they the same? Because this line here, which is RV, is parallel to this line here, which is PT. And because they are parallel, these two angles will be alternate angles. So it's basically looking like this, right? Watch it. I'm giving you all a little visual on this side here. It's like you have PT here, you have RV here, they are parallel. You have the line RT running here, boom. This is RT, right? And then you had a line above here, boom, right? Ooh. And then you had a line below here, bam. So this angle here is equal to this angle here, and they are alternate angles, right? These two angles are equal. Everybody seen it there? That is what is going on in between there, in that little diagonal region in between there, right? So RTV, which is this green angle here, is equal to PRT. So I'm putting P to R to T here. Talk done. So I'm saying it again. I don't realize the recording wasn't running. So we need to know a circle theorem to be able to figure out this question. I never did circle theorems with you all, but it is not hard to understand, right? It's basically angle in a semicircle is 90 degrees, right? So anytime you have a diameter, everyone should know that a diameter is a straight line that goes through the center of your circle, right? Anytime I have a triangle being formed of this diameter, like boom, bang, the angle for, well, at the circumference here would always be 90 degrees. That's what we mean by angle in a semicircle is 90 degrees, right? Sometimes you can say angle at the circumference in a semicircle is 90 degrees, right? It's the same thing, okay? So if I pull a next angle down here, once that triangle is formed of my semicircle, boom. Once it is formed of the semicircle, you're actually seeing it. You're seeing it, right? This here would be 90 degrees. Angle in a semicircle is 90 degrees, right? Everybody seen that? So let me go. I will. Anyway, that just means that this angle here is 90. So knowing that information now, I want you all to figure out the question for me. Go. So the diagram below shows a semicircle with diameter AC. So this is the diameter, meaning that the center of the circle is on this line, right? B is a point on the circumference, and AB is equal to BC, which is equal to 8.2 centimeters, right? Aiden Jutram, board is here, right? So 8.2 is the length of BC, which is the same as AB. So can I write 8.2 here? Everybody good there? 8.2. Now, state the geometrical name of the line AB. What AB is if that is a circle? Let me see who knew that. What AB would be? Here to here. What that line would be? Is it the diameter? Is it a radius? What is?
Radius.
No, it's not a radius. Look at radius here. This is a radius here.
Is it a chord?
It is a chord. Big up yourself, Denicia. Right? A radius would be half of this diameter. This is a radius here. Half of the diameter, that will be a radius. So, the geometrical name for the line AB would be a chord. Okay? It's a straight line that goes from one end of the circumference to the next, and it doesn't pass through the center, right? If the line passes through the center, it would be the diameter. Everybody good there? So that's a chord. I'm feeling like real people didn't know that. You didn't know that, Roshana? You didn't know that, right? We pressure boy, Kaden George, you didn't know that? So find the value of the radius of the circle. So if you want to find the value of that radius of the circle, what are your ideas? What's the first thing we should do here, Hamid? What do you think is the first thing we should find? AC, which is the hypotenuse, right? Now you find the people hypotenuse now. And then when we find the hypotenuse, what we doing? We busting it in two. Because we want the radius, right? So let's work with the hypotenuse, right? I'm doing it underneath here. So this is part 2. This is A part 2, right? A part 2. So A squared is equal to B squared plus C squared, right? So A would be my hypotenuse. So it would be AC squared is equal to 8.2 squared plus 8.2 squared. AC would be equal to the square root of what?
134.48.
Proper, right? So therefore, AC, which is the diameter, would be equal to what? 11.6 centimeters, right? 11.6 centimeters. So therefore, my radius would be equal to 11.6 divided by 2, proper. So my radius would be?
5.8.
Come on, guys, come on. You had a winner now. So in order to do part B, which is telling you that each interior angle of a regular polygon is 160 degrees. Calculate the number of sides of the polygon, right? So it's like I want to find n. Somebody mic on, right? So the formula I'm going to initiate would be this formula, right? So I'm saying the sum of all interior angles in a polygon being a shape with 3 or more sides, right? So a polygon would be from a triangle going up the road, right? So a polygon is 3 or more shapes in the side, right? And I'm saying that this is given by n minus 2 multiplied by 180. That will be the sum. Sum means the what? Add. So when you add up all the angles in a regular, well, any polygon, you will use this formula to get the sum of all the angles, right? This is as the sum of all angles formula, interior angles, so meaning inside the polygon. Now there's a very powerful word that they use here that CXC loves to use, right? Regular. So this word regular means that the sum of all the sides, well, the angles, all the angles in the triangle would be equal, all the lengths in the polygon would be equal. Did I say triangle? I mean all the angles in the polygon, whatever it is, whether it be a triangle or whatever, it will be equal. And all the angles and all the sides would be equal. So let me write that. So a regular polygon has equal sides and angles. All sides and all angles are equal, right? So we're going up here. So if I say each interior angle of a regular polygon is 160, each interior angle, right? Calculate the number of sides in the polygon. So it's like any you want to find, right? Now, if I say each interior angle is 160, all the interior angles will be the same. So I could actually form an equation here now. So 160 multiplied by n, or 160n, would be equal to n minus 2 multiplied by 180 degrees. Right? This is the equation we need to form in order to find n, which will be the number of sides, right? N is the number of sides. And why did I multiply 160 by n? We're going up here. They said each interior angle, right, in a regular polygon is 160. Each angle, so if I have 4 angles and each angle is 160, the sum of all the angles will be 160 multiplied by how much angles you have, right, by 4. So that's why I use n. So we go in here, I'm going to send this down. So here what we could do, two things. You can multiply this 180 by this and this 180 by this and then simplify, right? So this will be 160n is equal to 180n. 180 multiplied by negative 2 will give me what? Negative 360, right? And then what do I do next if I want to find n here, Hamid? What I'm moving next? The 360 or the 180? What I'm moving? I want to put all the n's together. 180. So this is plus 180. When I bring it here, what am I doing with it? Adding it still? It's plus on this side, it'll be minus. So this will be
Minus
1. Yeah, right, very good. Minus 180n is equal to negative 360. 160 minus 180n. 160n minus 180n will be how much n? Negative 20n is equal to negative 360. What do we do with the negative 20 when we bring it here? So n would be equal to negative 360 divided by negative 20. Therefore, n will be equal to 18 sides. Right? That's how much sides in the polygon. Right? So that's a fun little thing to learn there. Full analyzing of the question. Right? I see it once again. We see now a cone. The cone is made of a semicircle and an isosceles triangle. We know if here's 15, there's 15. We know if there's 14.1, there's 14.1. We know that here is a right angle because above they said that PQRS is a rectangle, right? So all the information is given here. They said that O is the midpoint of RS also. This is the midpoint. So that means that this line is equal to this line. Everybody agrees? Look at this statement here. They said it here. They said O is the midpoint of RS. Everybody good there? Right? Cool. So we know all our information. I'm going to write this in here. Here's 15. Here is 14.1 meters, right? Let's see what the question is asking for. Determine the value of the angle OPQ. O to P to Q. Come on. If this is an equilateral triangle, right? How are we finding that angle there? O to P to Q. 180 minus 40 divided by 2. Let me function. Right? You're working, big brother. Right? So OPQ would be equal to 180 minus 40. This was, I didn't have a number, I just have a year. I just have January 2025. Alright? So this will be all over 2. Why am I dividing by 2? Because when I minus these and then divide it by 2, I'll actually get the length, the size of these two angles here. Right? So right, what is OPQ? Talk to me.
70.
70. OC. You hear? You hear? Lock in. Lock in. You can come here to lose. Right, 70. What are you asking us next, boy? Calculate the length of OR and OS. So let me see where OR and OS are located, right? OR and OS. Well, OR and OS will be the same thing, but what are we doing for that, boy?
OR and SR.
Oh. Why saying OS? OR and SR, but once you find OR, you can't find SR, right? What are we doing for OR? Let me hear that. Dog food. OR is what we're trying to find, eh? That line down there. So you need to split the triangle? No. What are we trying to find there? You trying to find what? A side or the hypotenuse? A side. Oh, let's see that triangle, right? I ain't really highlighted, but are you seeing which was it? What are the vertices of the triangle we're looking at? Let me see. O to
O to R.
O to R to Q. ORQ is the triangle I'm looking at, right? So I have my hypotenuse, which is how much? How much is my hypotenuse? I'm pointing it at axle 15, right? What is the side that I was given? 14.1. Let me function. Let us function. So if I want to find a side, I am using this formula, right? It's just like an edited version of the original formula. B squared will be equal to the hypotenuse squared plus or minus. Minus, proper. The other side squared. So B would be OR, that's what we're trying to find, is equal to hypotenuse was 15, I believe, minus the other side was 14.1. So OR will be equal to the square root of what? 26 point? 20 what? 29.19 hour again? No? Check it over. 29.19? Check it over. 15 squared minus 14.1 squared. And press equal. Minus.
26.19.
Come now, let's tell me dreams this hour in the morning.
26.19. Yes, sir.
26.19, right? So OR is equal to. Give me OR. 5.12. And this will be what was meters? I believe it was meters. So my brothers and sisters, if here is 5.12 meters, what over here will be bros and sisters? 5.12. Right? So this was OR. So SR will be equal to 5.12 multiplied by 2, or just 5.12 plus 5.12, and what we get? 10.24 meters. Right? Everybody good there? That was it. Calculate the value of OQR and pot of speed. Right? So there you go. OQR. That's this bad boy up here. I don't hear nobody say we're going to use no trigonometric ratios because they have a real easy way to find this. It is a right angle, sister. Very good. This is a right angle. And then we had this bad boy here. And we had this bad boy here. What here was? Here was what? 70, right? So what the small angle will be? 20. So OQR is equal to, you know what? On that pressure in an exam, you might go and use trigonometric ratios there on that pressure. I tell you, I might have done it. So when we do circle theorems, you'll realize that I might do a question, take a real long route, and then you realize it much easier than that. So here, on that high pressure, you might even think of that, but when you work it, you'll get the same thing, right? You'll get the same 20. So there you go. So OQR is equal to 90 minus 70, which is equal to, right, let me do the pos. P to O to S. That's down here. What's all the ideas down here? But what are your ideas? Let me hear you. I tell you, math's so beautiful, eh? So Roshana saw two parallel lines. Roshana saw two parallel lines, and she saw that this angle here, which is what we found to be 70, will be equal to this angle here because they are alternate angles. That's what Roshana saw. I didn't see that. I saw automatically here's 20, here's 90. So you add up the two minus it from 180. That's what I saw. Right? So I gotta use Roshana on. So this is equal to 70 degrees and it'll be alternate angles, right? Angle. Angles on a straight line. Because why? We had here? Yeah. If you had here?
You can just take 180 minus. You want to make that divided by 2 because 2 equal.
Right, the 2 equal. You could have done that. So you could have done 180 minus 40 divided by 2 here, and you would have gotten it. Correct? Because these two would be equal. So you see how much different routes you could take for these. In the diagram below, not drawn to scale, ST is equal to 6. So you see where ST is, yes, you are seeing that it's equal to 6. Then WR is equal to 11.2. WT is equal to 14.8 and the angle WRS is equal to 90. That's here, right? How is it we could have this triangle here? This is where I need to think outside the box, right? Nothing gonna come straight forward in CXC. Nothing, right? Calculate given reasons for your answer in, well, to one decimal place, the length of RS. Now, if I want the length of RS, block out the noise, which is this line here. Are you seeing a bigger triangle here?
Yes, sir.
Could I just find the length of RT and then minus 6 from it? Come on. Let's go. Right? So I'm going to find RT. RT would be a what? Which is from here to here. RT is what? Is it a side or is it the hypotenuse? Side. So let me call that B. B squared is equal to A squared minus C squared. So RT squared would be equal to A being the hypotenuse would be 14.8. 14.8 squared minus C, which would be proper. So RT will be equal to the square root of what? RT would be equal to centimeters, meters. Therefore, RS would be equal to 9.7 minus
6.
which is, so I found here to be 3.7 meters, right? The next thing they want us to find is WS. Focus on the smaller triangle now, right? WS will be my what? Come on. WS is my hypotenuse now. A question don't get much easier than this and all, yeah. Right? So there we go. Focus on WRS, that triangle now. So we want to find the hypotenuse, okay? So we go in make some space here. So WS, let me put the formula first. Says hypotenuse. So it'll be A squared A squared is equal to B squared plus C squared. A squared in this case will be W to S. So WS squared is equal to B 11.2, 3.7, right? Anything is anything there, right? So 11.2 squared plus 3.7 squared. WS is equal to the square root of what? WS will be equal to 11.8 meters. Top done?
Yeah.
I'll be here. I put these in because I see we have to find some angles, right? What was 11.8? Real close to this one by 11.8 meters, right? So the measure of angle RTW, right? RTW, let me go. R to T to W. What are you using? Sine, you can use anyone because you have all. You have all opposite over hypotenuse. So let me function. Right? So if you're using sine, sine of theta is equal to opposite over. So theta is the unknown. Theta is the angle, right? That is RTW. That's what we're trying to find. What opposite was? Anybody got a chance to write it down? 11.2 over my hypotenuse, which is not the hypotenuse of the smaller triangle, it's the bigger triangle. So that was 14 point something. So sine moving by itself. What sine becomes? Proper thing online. Right? So this will be equal to sine -1 of 111.2 over 14.8 What did I get RTW to be? How much? 49.18. So let us go 49.2 degrees, right? 49.2 degrees. Okay? Everybody good there? So that will be here. Here is 49.2 degrees.
2 degrees.
Right? What they ask us next? RWS. Right? RWS. R to W to S. There. What is little baby here? What if I any baby? What are they doing? What are you using? I just like sign. Opposite over. You have a new opposite now, eh? Over here, hypotenuse. Have any easier way to get this? Nah. So there you go. Run it. I run it right on the side here. So sine theta is equal to opposite over hypotenuse. I realize something, right? I just write that formula. What come and do here? Write it back. What I doing for you? Sticking it in your head. Sticking it in your head. If all this stick to what I doing, it had no way you could feel it. No way, no. Stick to it. Do not be lazy. Laziness is the only thing that has make people fail, you know. Laziness is, you see Mr. Said writing the formulas over and over. You see Mr. Said writing notes. Sometimes I write a note last day and I come back and write the same note today. And you're lazy because you're telling yourself that done in my book. And I've experienced that a lot. And that's why there's no deterrent who went serious. I don't care if I write it, I'm writing it again. Right? It's so that it will stick. So this will be sine of RWS is equal to opposite what? Opposite was 3 point something. Over sine moving by itself. What is that? Just so? Right. So RWS is equal to sine -1 of 3.7 over 11.8, which will give me what? 18 point degrees, because it's an angle.
Right, so go on, okay?
All right, on pause. So we're going to look at parallel lines now, right? So parallel lines run side by side and never meet. Corresponding angles are equal, right? So once I have a pair of parallel lines, once you have angles in the same position on both lines, right? Each parallel line, they are equal. Alternate angles are equal. Alternate angles, please note that alternate angles will always be inside of the pair of parallel lines, right? So if we have alternate, you all know what alternate means, right? On the next side. So if you have an A here, on this side will be B, these are alternate angles, they are equal. If you have X here, and here's why alternate angles are equal. Co-interior angles add up to 180 degrees. Co-interior, you all hear the word interior, it's inside of the pair of parallel lines, right? So this angle on this side plus this angle on this side would be would add up to 180 degrees. These two angles will add up to 180 degrees also. Which two angles here are alternate? Let me see you following. Which two angles here are alternate in this question? A and Y, very good. X and B, very good. Right? So they're locked in. Right? Once you see a X, look for a X. Once you have an X, vertically opposite angles are equal. Right? A is equal to B. Angles at a point on a straight line add up to 180 degrees, right? So all these bad boys here, A plus B plus C, add up to 180. And angles around the point, which is like a complete revolution, would be 360 degrees. Everybody good there? So we're going to jump now, you know? We're going to jump. I think I want to test all here. So the diagram below, not drawn to scale, shows a parallelogram. I showed you all some parallel lines laws, and then I came and gave you all a parallelogram. Were you all able to decipher that they had two pairs of parallel lines? You all were able to decipher that? So if we're looking at, yeah, right, very good. So they gave us this line as 6, this line as 8, which really don't do nothing for the question, right? This angle here is 60. They asked for A to D to C. So we're asking for this bad boy up here. How do I find that bad boy? What do I do? ADC will be equal to 180.
Minus 60.
And what is the reason for doing this?
Because we trying to find
What's the name? The name. Give me the name. Co-interior angles add up to 180. So you have a parallel line here. Boom. This is one parallel line, right? Okay. This is your other parallel line down here. And then this line here serves as your transversal. You all seen it? This is your transversal here. Okay? Forget the fact that we have our next parallel line on the next side, right? This is your transversal. So if you have your pair of parallel lines and a transversal and you want this angle here, given this angle here, you do 180 minus 60, co-interior angles add up to 180 degrees. So this will be equal to how much? And I'll just put co-interior angles.
120 degrees.
Co-interior angles. Alright? Okay? BCD. What are we doing for BCD? Let me hear there. Here's 120, right? What are we doing for BCD? Go ahead. Go ahead. Go ahead online. It is 60, but what are we using? This angle here is what we're trying to find. BCD. This angle here, right? This angle is co-interior with which angle? Huh? This angle and which angle are co-interior? This angle here and which angle? This and 60 are co-interior? 120. Right? This is another pair of parallel lines here. Boom and bang. This is another pair of parallel lines. And then you have another transversal here. Bang. Right?
So C is 120.
C is not 120, bro. C is not 120. Co-interior angles add up to 180. Right? So BCD would be equal to 180 minus 120, which will be 60 degrees. And the reason will be co-interior. Your mic on, bro? Crow, your mic on. Co-interior angles add up to 180 degrees. And what should be going on in your brain, bro? June 2024, right? So we're going in the diagram below. PQ is parallel to MN, right? So that's supposed to be in your brain already, right? Just showing you know that two lines are parallel. LRT is an isosceles triangle. LRT is an isosceles triangle. So if LRT is an isosceles triangle, what does that say about these two lines? Equal. And what does that say about these two angles?
Equal.
That is the main piece of information here. Right? And then they said that SLT, that they just say that this is a straight line, right? So if we find these two angles here, what we could find after that? Let's find the two angles first. So I'm gonna find LTR, right? So LTR would be equal to 180 minus 28 all over 2, which will give me what? 76? Somebody second now, 76? Huh?
Yes, sir.
76 degrees, right? Now if he has 76 degrees, I put the 76 here also, right? But if he has 76, where else would be 76? Up here. Up here would be 7. No, not X at all. Here would be 76, right? What kind of angles are there? What kind of angles are those? Proper. So PLT is also equal to 76 degrees because they are alternate angles, right? And then what I could plug in here now?
76 plus 78.
76 plus 28. Why are you adding 28 to that? What? Why are we using 28?
Then find T.
You gotta find x. What we could use here? 180 minus 76. Because why? Angles at a point on a straight line. And this question said that SLT is a straight line. Right? Look at it right there. So if this is a straight line, angles at a point on a straight line, meaning these two angles here at this point would make a 180 degree angle. Right? So x would simply be equal to, so I can put therefore x is equal to 180 minus 76, which will be,
So, but if you did add 76 to the 28, you will get 104.
you'll get 104. But trying to see what it is you're using to find that. You know why? Because if he has 28 and then he has 28, right? Alternate angles again, right? Right? Alternate angles. But what's something? This angle here and then this angle behind here will be vertically opposite. You all seen it? They would have been vertically opposite. Right? This angle here, let me put it in red. I'll show you again. This whole angle here, because all you do something, I want you to understand what you all do. This angle here and this angle behind here are vertically opposite. Why? Because see if you all see the x. Once you have an x, boom. Once you have this here and this here, you have an x. Right. Vertically opposite angles are equal. Everybody good there? January 2014, it says in the figure below, not drawn to scale, meaning that it is, you can't take a protractor and measure these angles. It is not drawn to scale. The lines AQB and QRPD are parallel. What does parallel mean again, Dominic? What does it mean for two lines to be parallel?
Parallel means two lines that are facing the same direction but never touch.
Never touch. You're running side by side, they never touch. Right? Right, Mr. Aiden Ramjan? No, that's not. Yeah.
Also, sir,
Yeah, go ahead, Dominic.
the second line is CRPD, not QR. You said Q instead of C.
CRPD. Which line you talking about?
After AQB.
Okay. Sorry about that, guys. I said Q is supposed to be C. CRPD. Alright? That's the second line. So let me go. So remember what we did last day. Let's just review that quick. Right? Because I've seen some new faces here. Right? So that's a quick review. Right. Corresponding angles, right? Corresponding angles are in the same position on the different parallel lines, right? So if you have an angle in this position here, on this parallel line up here, it will be in the same position, right? You have a transversal cutting up here of parallel lines corresponding here. Leave that one on. Corresponding angles would be A and B. Corresponding angles will be X and Y, right? You also have corresponding angles under here and under here also. Alternate angles. The thing about alternate angles is they must be within your parallel lines, right? So this angle on top here will be equal to this angle under here. And X will be equal to Y. They are alternate angles. Co-interior angles. Co-interior angles add up to 180 degrees, right? Meaning that A plus B would be 180. Also, X plus Y would be 180, right? Vertically opposite angles are equal, meaning that if you have an X, the angle on one side is equal to the angle on the next side, right? The angle on top here is also equal to the angle under here, right? Angles at a point on a straight line add up to 180 degrees. You have a point on a straight line, all these angles add up to 180. Angles around that point, complete revolution is what we're talking about, would be 360 degrees, right? So you have a point here, all these angles around here add up to 360. So we're jumping back here now. So we're dealing with Mr. X first. Mr. X is probably the easiest. They said calculate given reasons for your answers the value of X. So let me go. What is the value of x? And give me my reason. What is x?
Your x is 28 because
28 and y.
because the alternate angle.
Alternate angles are equal. Proper thing. Let's write. So this is part 1, right? So, well, it's x we're trying to find, right? So x is equal to 28 degrees. And your reason would be alternate angles are equal. Everybody good there? Right? So this angle here would be 28 degrees, right? Let's proceed to find y. What you're thinking for y? I'm seeing that these two lines are equal. So what can we find? Which angle can we find? Come on, you all answered this morning. Let's go. What angle can we find? Hello? Which angle can we find here? Give me the, when I say which angle can we find, give me the letters that represent that angle. What to what to what, Brendan?
So R to Q to P.
R to Q to P. That'll be this one here. But if it's an isosceles triangle, this angle will be equal to which angle? R, aka QRP. Right? It's this angle on the side. Because when you tell me R is this point here. So I don't know which angle you're talking about when you tell me R. Eh? Tell me QRP. So let's find QRP first. Q to R to P. QRP will be equal to what? What's the work in here, my children? Come on, speak up.
180 minus 28 divided by 2.
Proper. Who said that, Nkosi?
Yeah.
You see why when I come in school, Amelia, others feel to fight Nkosi. Brains, boy, I know all it is, but I don't know, boy. Oh God. There we go. So what is getting me here? Chloe, where you get here, sister? Anybody? I think Chloe. 76 degrees, right? 76 degrees. So that is QRP because QRP is what I'm looking for. And what am I going to apply now? This is QRP, right? Oh, let me just put the angle here. All right, in QRP. This is 76 degrees, right? What's the reason I put in here? What's the main reason I applied here?
Interior angles add up to 180.
No, it wasn't interior angles. You all saw how I got this, right? What's something? This was the triangle, right? Well, that's not the triangle. It's an isosceles triangle, right? I realized I didn't understand what I did there, right?
These angles and isosceles are equal.
Very good. So this was an isosceles triangle, right? This was 28 degrees. Okay? Good for people waiting to come in. What the hell? All these people come from this hour. Right. So the main law I used here was base angles, being these two angles here of an isosceles triangle, are equal. Right? You understand why it's not co-interior, Dominic?
Yes.
Co-interior meant that this entire angle here, which would have been this and this, when you minus it from 180, you will get 76 here. But we did not have the entire angle. So that's why the main law I used here was base angles in an isosceles triangle are equal. Could we please write that in? Base angles of an isosceles triangle are equal. So how do I proceed to find y? And what am I using to find y? Give me the law.
So yeah, what I used to.
Go ahead and go see.
You can use alternate angle as well.
No. We want y.
So yeah, why do I
Go
I take
ahead.
70. I use 76 plus 28 and get 104.
76 plus 28. Now that is that the answer? That is the answer, but
But no, you can minus the 104 and 180.
right, but 104 minus 180. So give me the reason. So let's tell him the things, but you had to give me the reason. What's the reason, Brendan? What's the reason, Nekosi? Because you right to Nekosi. Or what's the reason you put with the answer?
Correspondence angle.
Right, very good. Very good, Nekosi. Corresponding angle. So what Nekosi did is he add these two angles here, the 28 and the 76. Remember, here's 76 also. And this red angle here, this whole thing, would be corresponding to this Y angle here. Right? And then Brendan, what's the reason you using? Because you said 180 minus 76. And what would be your reason for Y?
My answer, I get 36 degrees, but I find y and 28 look kind of alternate, so I think I might get
No, alternate angles must be in between a pair of parallel lines, bro. So unless you're working in between these two parallel lines here, it can be alternate.
So I get the answer right, but I get the reason wrong.
Right, but I want to know the reason why you did 108. I'm sorry, 180 minus 76. Anybody want to help him?
Vertically opposite?
No, not vertically opposite.
And look at that point on a straight line.
Very good. Very good. Very good. So, what Brendan used, and he didn't even knows that he used, is he used angles at a point, this red point here, on a straight line. So, these two bad boys here would add up to 180 degrees. You seen it here, Mr. Brendan?
Yes.
So, whichever one you use, it's okay, right? I will use the angles at a point, right? So, I'll put y is go ahead.
What is the type of angle in red?
When you say type of angle, what do you mean?
Like the name of it.
Which red? Which red? This red here? Y?
Yeah, the one with Y and R and X and the 76.
Y and R and X and 76. When you say what we call it, I'm not sure. What do you mean? Like obtuse, acute, reflex? Is that what you're talking about?
The name of the angle, like the reason and like it.
For which one? Tell me which one you're talking about.
Y and R.
So this will be equal to 104 degrees. And my reason will be angles at a point on a straight line add up to 180 degrees, right? Make sure you have that.
Yes, sir.
So you see this angle that is in green, which is x and 76. This entire angle is vertically opposite to z, right? Because if you look here, you'll see the x. Boom, bang. There's an x. And I gave you all a law stating that once you have an x, the opposite angles are vertically opposite. So this angle z will be equal to this angle underneath here, which will be x 28 plus 76. So I'm simply going to put z. So this is all I'm going to put, right? I'm going to put z is equal to 76 plus 28, and then I'll put my reason as vertically opposite angles are equal, right? 76 plus 28, which is what? 104. Vertically opposite angles are equal. Right, so January 2022, the diagram below shows 4 straight lines, 2 of which are parallel. So these 2 lines are parallel. So once you see parallel lines, you know we could activate corresponding angles, we could activate alternate angles, we could activate co-interior angles, right? Once you see these parallel lines. So we started with R. They said determine the value of R and Q, give reasons for your answers. What would be the reason that what would be R and what would be the reason for your answer? R is equal to what?
54, 54.
And what's my reason?
Vertical.
Proper.
Because the opposite angles are equal.
Proper. Proper. Vertically opposite angles are equal. Right? Vertically opposite angles are equal. We go into Q now. What will be Q?
So Q will be 180 minus 54.
Reason.
Coequal angles add up to 180.
Proper. Give me the answer here.
126.
So I put 71 degrees.
Where again?
I put 71 degrees.
Where you get 71 from? So Q and R are co-interior, right? We found R to be, let me write R here. R was 54 degrees. Then these two angles, which should be 54 and Q, would add up to 180 because they are co-interior angles, right? So if I have R, I can find Q. I'll simply do 180 minus 54 and I will get 126. Right? I hope the person, if you're still getting any problems, let me know, right? 126. So I need to put my reason. Co-interior angles add up to 180 degrees, right? The last thing they want us to do is to give a geometrical reason why angle P is equal to 71. What would be the geometrical reason why angle P is equal to 71?
Because they are
Alternate.
angles are equal.
Proper. Very good, guys. I like how plenty people answer, and that's what we talk about. Right? So I hope you all have it there. P is equal to 71 degrees because alternate sure, no problem. Did I finish right out this reason? No. Because alternate angles are equal. Right? I hope you're getting through these things, and they flow in. Right, let's go. So men say they're stuck on C. So let me go. The diagram below, not drawn to scale, shows two triangles, right? JKL and MLP, with JK parallel to MN. So the only two parallel lines would be JK and LM. Pay particular attention to that. Now LM is equal to MP. Ooh, LM is equal to MP. That's a vital piece of information. You see why it's very important to read your question. Go ahead, Amelia.
So M equals to MP equals the triangle. MLP is an isosceles triangle.
Correct. Then it said KLP is a straight line, right? K to L to P is a straight line. Angle JLM, J to L to M is 22, and angle LMP is 36. That's all the information they gave us, right? So calculate, given reason for your answers, the measure of each of the following angles. So we're dealing with Mr. MLP first, right? So this angle here is located by L. M to L to P. Come on, that dog food.
Can I try?
Yeah, go ahead.
But two base angles are equal, so the two ones are equal. So MLP plus LPM plus 36 is equal to 180.
Mm-hmm.
And so I got nervous there, but
That's okay.
take away 36, so make it 144. And when you divide it by 2, you make it 72, which is your answer.
Excellent, Amelia. Excellent. And what would the answer
I
be?
get a dog, so that I exactly like dog. So I get
I never know, Missy.
That's okay, Amelia. Don't worry, you're in a safe space here. What's your final answer there? Brendan, what's your final answer?
2.
How much?
72.
72 degrees. Right? Did they ask the reasons? Ooh, yeah, they did.
Yes, so because MLP equals to MP, which is
So we could just say base angles.
just each angle, huh?
Yeah, we could just say base angles in an isosceles.
Because two base angles are equal, huh?
Right? Everybody good there?
Yes, sir.
Let me keep it moving, right? I'm gonna send this bad boy down a little bit. You go down. Right, so we go into L, J, K. Right? So
Number
L,
2 is transversal.
right? Let me locate L, J, K, right? So L to J to K is right up here. So what that'll be equal to and what's the reason?
It equals to 22 degrees, sir.
And what's the reason?
Because the alternate how you pronounce the word?
Alternate angles. Alternate angles.
Angles equal, sir.
Amelia, you come a real long way, eh? So do not be ashamed and do not shrink. Rise to the occasion, eh, sister? I'm telling you that.
Please.
Yeah, go ahead, big bro.
The alternate interior angles are equal, sir. That's
Not interior, sister. What you say? Co-interior? Co-interior angles add up. Co-interior angles add up to 180. Alternate angles are equal, meaning that if you have an angle on this side here, 22, and you have an angle up here, these two angles would be equal. Right?
Corresponding angles are equal.
No, that's wrong. You're getting that wrong in an exam. You're getting that wrong. Corresponding means that these on opposite sides. It's like you have a parallel line here, you have a parallel line here. It's like this 22 is under the transversal, and then the other 22 is above the transversal. Corresponding angles will be on the same side of the transversal. Right, Nikosi?
Yes, sir.
Right. So JKL, right? So we have part 3. This will be JKL.
JKML and PL is on the same line as LP, sir.
Let me locate it. JKL, right? JKL would be this.
ML and KL is on the same line as LP, sir.
Right. I see what Brendan was saying.
Say take a minus 180 minus 72 and you'll get 108.
72 alone?
So it's 72 degrees for number 3, sir? Yeah.
Alright, yeah.
I'll do 72 and 36 and take away from 180.
Proper.
You can do that.
Proper. The angles.
Both of them is the same straight line as
Right.
LP, sir.
So listen to what I'm saying, eh? The angles at a point on a straight line add up to 180. So when Nikosi said that it will be 180 minus 72, that will be giving you 22 plus the other angle, right? So it's 3 angles at this point here. So if you want to find this angle here, it would be 180 minus 72 plus 22, right? So this will be equal to 180 minus 72 plus 22, and this will give me what?
86.
96 or 86?
96, sir.
Yes, sir. I also got 96.
Alright. That'll be 94. Are you sure?
Oh, wait, no, sir.
Yeah.
Since 86.
Yeah, 86. So angles at a point on a straight line.
So it could be 86.
Because this, when you add up this, you'll get 94, right? 180 minus 94 would not give us 96. Right, so angles at a point on a straight line add up to 180 degrees, right? So point to note that because I find people was lost as to what we were doing there. It's like you have a straight line, you have a point, don't matter how much angles I have at this point here. So it could be this angle plus this angle plus this angle plus this angle plus this angle. All those angles add up to 180 degrees. We good there, Abraham? Abraham and Abraham. Right? So that is JKL. So we go to the last part here, which should be KLG. So K to L to J would be equal to K to L to J. Wait. We ain't finished fine. We ain't finished fine JKL. JKL is not this.
It's 72, sir. That what I got, sir.
Hold on. That's all. I could send this down. That's all right. Let me send this down. Hold on. So
I don't know, but I get 108.
that's all. This what we found here was JLK, right? JLK is equal to 86, right? So this is J to L to K, J to L to K, which is the last part I don't understand. Right? J to L to K is equal to 86. So therefore, how I was going to find my JKL, right? Is JKL, right? Right, JKL. I was now going to do, if here is 86, right? The three angles in a triangle add up to what?
180.
Right.
180.
So that is what I was going to apply in order to find JKL. But I see the last part is asking us to find JLK, which we already find. So this will be 180 minus 22 plus 86. 22 plus 86. Are we getting here now? 72 degrees. And
Yes, sir. I was correct.
yeah, it was correct. Angles in a triangle add up to
So I thought I got it wrong, eh?
180 degrees, right? So I could have used corresponding angles here, right? So MLP, which is 72, would have been equal to JKL, which is also 72 because they are corresponding, right? Now, in real time, sometimes you don't see all them things when you're doing this in our exam, especially with things like parallel lines and circle geometry, right? You might take a longer route, which is okay. So all you have to do here for this last one is just come and put that KLJ is equal to 86 degrees, right? Because we already found it up here. Okay, and the talk done there. Right? Are you ready to run?
Finish.
Let's go. So I gave you all a little note here before you start this question, right? It says the sum of the interior angles in any polygon. A polygon being a shape with 3 or more sides, right? So we talking about triangle, rectangle, any kind of quadrilateral. The sum of all the interior angles, when you add up all those bad boys, you would get this. Well, you could use this formula, right, to get the answer. It will be n minus 2 multiplied by 180, where n is the number of sides. How many sides does this figure have?
5.
5. So we know n is 5, right? But anyway, that's a part 2. Let's go to part 1, right? They said, all right, let's check out the information above here. They said the diagram below shows the pentagon VWXYZ. In the pentagon, YZ is parallel to XW and YX is parallel to VW. The angle XYZ is equal to 114, that'll be here, and then VZY is equal to 98, right? So, determine the value of angle WXY. So, where is WXY located? WXY will be this bad boy here, right? In order to find this angle here, because we have two parallel lines, boom, 1 and 2 here, And we have a transversal in between those parallel lines being this XY line here. So this XY line serves as a transversal now. Okay? So this is like my transversal here. So I'm going to drop the whole line. So you all see the transversal there? So if this is a transversal, what will these two angles add up to?
140.
140.
183.
And what will be the reason? What?
Alternate angles are equal.
Angles on a straight line add up to 100.
So I hear somebody say that. Co-interior. Where you see that triangle here, big brother?
114.
Co-interior angles. These are co-interior angles, right? Co-interior angles, right? That will be this angle and this angle. You have a pair of parallel lines, watch it there. 1, 2. You have a transversal running across, boom, right? This angle here on the inside plus this angle here on the inside, these two lines are parallel, add up to 180. So A plus B is equal to 180. They are co-interior. So 114 plus the unknown angle will add up to 180. So what would my working look like? Let me hear you.
180 minus 114.
Equals to
66.
180 minus 114 would be equal to 66 degrees, and my reason would be co-interior angles add up to. So everybody clear here? Because I hear all kind of different answers just now. I hear people saying angles at a point on a straight line. Angles at a point on a straight line, my children, will be like 114 and this angle behind here. It will be like this here and this angle behind here. So these two would add up to 180 on the left, and these two on the right here will also add up to 180. That's how angles at a point on a straight line add up to 180 works. Are we clear? Right? So let go. Now the next one, this is where you have to think, right? We just found this, right? Put that in, right? We just found this to be 66, right? This would be 66. This is where you have to think. This is where maths helps you to think critically. People don't understand what maths does to your brain. It does a lot more than what it seems. Or you tell yourself, boy, I'll never use this again in my life. But maths is unlocking that logical thinking, that critical thinking gene that most of us are not born with. Right? So let's go. What do you think we need to find first? I'll give you only one hint. You need to find something first before you could proceed to find what they ask you for. What we need to find first?
XWV.
XWV. Excellent. XWV, we must find that first. Right? So when we find XWV, well, not when, how do we find this angle up here? How do we find that angle up there? Let me hear you all. Co-interior angles is one. You see like what changing the subject of the formula is to algebra. Co-interior angle is to parallel lines and bearings and even circle theorems. It's one of the main theorems that you must know, right? So co-interior here again.
Sorry, sir. I got kicked out because
No problem. I see about 5 people leave the chat one time. So I realized something went on. Yeah, go ahead. So let's proceed to put the work in for XWV, right? So XWV is equal to 180 minus 1, it's now 166, 66. And this will give me what?
114.
114 degrees. And the reason will be the same as above. Co-interior angles add up to 180 degrees, right? So I found that angle there, right? So I need to wait, we're going there, Jessel.
What number is it?
We just on January 2021. Remember, all of them will be the number 3s. It's just the number 3s in these past papers, right? So let go. We found here to be 114 degrees, right? So I gave you all a rule to the right there. I said the sum of the interior angles will be n minus 2 over 180. Right? So n minus
3 multiplied by 180.
so right, so the sum of the interior angles, I'm gonna put that here. So the sum of the interior, meaning the angles on the inside, interior angles would be equal to write the formula over here. So n in this case was 5 minus 2 multiplied by 180. What is the sum of the interior angles?
540.
540, right?
Yes.
So 540 degrees. But how much angles we missing up here?
That one more angle to find IV.
So if all the angles add up to 540, how do we find the missing angle?
So by minusing all
Add up the angles you have and then subtract it by the total, which is 540.
So everybody make sure they have them, and we're gonna write them underneath. So what we're gonna proceed to find here now would be, you saying something, Amelia? Rello, I barely hear here. ZVW would be equal to 540, which is the sum of all the angles, minus, I think it was 98 plus 114 plus another 114 plus
A.
66.
66.
Yeah. So what is ZVW, which is the last unknown?
148.
140.
148 degrees. Right? Who does not understand this? Now you have to learn this formula. This formula is trending right now in CXC. Yeah? It's a trending formula. CXC bringing out a lot of questions with these. So this is January 2018, the regular polygon EFGHIJ shown below has center O, triangle OEF is equilateral and EF is equal to 5, right? What does equilateral mean?
All sides
All sides are equal.
So if all sides are equal, right? What that's saying about all the angles to by?
All the angles equal.
And what will be all the angles in a triangle? What all these angles will be?
60.
Proper. So know all of that from just them telling us that it is an equilateral triangle, right? Okay, that's everything you know there. And all it done see how much triangles they can get here. And all the triangles will be the same because it's regular. So don't stick with this, eh? This is food. I'm mapping it out for you right now. All you hear that noise outside, they're digging up the road by. You all hearing it here?
Yeah.
Sir?
If somebody say they hearing it. Right, so they said calculate the perimeter of the polygon EFGHIG, right? We already stated the name of the polygon. It's a regular hexagon, right? Because it has 6 sides. Now, we calculate the perimeter of the polygon. I can do that right here. What we adding together for the perimeter? Come on. Or you could just say 5 multiplied by how much sides we have?
6.
6. So it would be,
30.
right? Determine the size of each interior angle of the polygon. They told us it's an equilateral triangle. So if here is 60, what the next side here will be?
60.
So the total or the size of one interior angle would be 60 plus 60, which should be
120.
That's done.
So I
Right?
have a question.
Go ahead.
Can you just find the sum of the interior angles and
That-
just divide it by 6?
Yeah, that's why I gave you the formula. In case in real time you don't see that what I just said there, you could just use your formula. Right? So just use you could just use 6 minus 2 multiplied by 80. Whatever you get divided by 6 and you will get your answer.
So that would be 720 divided by 6 equal 120.
Right, you'll get the same thing, right?
Same answer.
Same answer. So we go now. Now, I would find the height of one of these equilateral triangles, right? In order to find the height of this equilateral triangle, I will need to draw this line down the center here and establish that one side of this line, well, this entire line here, half of this entire line would be 2.5. So you have your hypotenuse, you have one side, you want to find the next side, right? So the formula we're using is b squared is equal to a squared minus c squared. So b in this case is what we're trying to find. I'll call it the height of the quadrilateral of the triangle. Sorry, is equal to what is my hypotenuse here again?
5.
So it'll be 5 squared minus what is the other side again?
2.5 squared.
2.5 squared. So h will be equal to, you're doing the opposite of squared on the side, which will be the square root of what? Square root of what? Come on, quickly.
18.75.
Right? So what h will be?
4.33.
So therefore, the area of one triangle. What's the formula for the area of a triangle? Hit me.
Base by height divided by 2.
Proper. Divided by 2. So my base would have been 2.5. No, let me do the full base. You can use the full base of 5. Find for the full equilateral triangle. Because if I find out for half of the triangle, I'll still have to multiply by 2. So we're doing the full base, which is 5, multiplied by what's the height? The full base is 5. Right? From here to here is 5. Okay, 5 centimeters. What is the height? What did we just calculate the height to be?
4.33.
4.33. And this will give me what? Yeah, go ahead.
10.83.
10.83. 10.83. Right? And this will be centimeters squared. Somebody mic on. This will be centimeters. Right? So the area of the polygon, how many triangles do we have up here again? 6. Right. So this will be equal to. Yeah, go ahead.
When I calculated it, I get 10.825.
Right, which is 10.83, correct.
Alright.
And what is it be equal to?
Which is
64.98
centimeters square. But if you're doing it in a
So they said, right,
5 centimeters square.
this is very important, to the nearest whole number, right? So it will be approximately equal to 65 centimeters squared. Right, so parallel box to indicate that it was shown. So before we even go into this question, right, this is January 2017, right? Similar triangles have the same shape and same angles but different sides, right? Now, the sides are proportional. They said angle PQR and STR are similar, right? Meaning that if I want to separate them, right? So it's like, let me leave RPT here, right? RPQ, sorry. Leave RPQ here. That's RPQ. And then I'm putting R to S, S to T, and T back up to, I want to make this a little longer. All right. So this here will be SRT. They are the same triangles, right? Meaning that this angle is equal to this angle. This angle here will be equal to, let me put them in different colors. This angle here will be equal to this angle here. And then this angle on top here would be equal to this angle on top here, right? They just put the two triangles in one. Okay, Brandon? The two triangles are in one. So, complete the following statement. In the diagram above, the corresponding angles of PQR and STR are equal. Are equal. Right? The corresponding angles are equal. Okay? And the something of their corresponding sides are the same. Their scale factor. Or you can put their ratio. They often say their ratio. Right? And the ratio of the corresponding sides are the same. Meaning that if I multiply ST by 2 to get PQ, you have to multiply every other side by 2 to get the corresponding side. Right? That's how easy this is. Then they said in the diagram above, not drawn to scale, RS is equal to 15 centimeters. RS, so R to S is 15. So that'll be here. Putting it in this one, This is 15 centimeters, right? SP is 9. S to P is 9. That's this little piece down here. S to P is 9 centimeters. That from here to here is 9 centimeters, right? ST is 12. S to T is 12. That's down here. So let me ask a question. What is the length of P to R? Let me see who really following. What is the length of P to R? Let me see who following. We have S to R. We have P to S. What will be P to R?
Plus 15.
Proper. Right? Men following. Wow, somebody said the answer. What you said?
24.
20 how much?
24.
Right, so 24 centimeters is the distance from here to down here, right? Okay, that's 15 and 9 here. 15 and 9, right? Now, if I want to figure out what the ratio is that separates SR from PR, I simply have to divide it 2. So I'll show you what I mean, right? What they ask us, determine the length of RQ. Where's RQ? R to Q. Oh, that's the next side. On that side, R to Q. So we do.
We had to find QT and then RT and then add those two again.
We had to find what it. So that was a misprint, right? It's only PQ they need you to find. So what I'm going to find first would be the ratio, right? How do I find this ratio? So look at this here, right? Your ratio, I get blue ink. Your ratio would be given by, if this line is 15 and the corresponding line is 24, to find the ratio, it would be 24 divided by 15, which will give me what? What is the ratio that separates my lines? My sides? What's the ratio? 24 divided by 15, anybody?
1.6.
1.6 is the ratio, right? So therefore, PQ would be equal to 1.6 multiplied by its corresponding side, right? So PQ is the base here. So what side in this triangle corresponds with PQ? Let me hear you all. What side in this triangle is in the same position as PQ?
ST.
ST, which is 12. So you multiply 1.6 by 12, and you will get what PQ is. What you get it?
90.2.
90.2 centimeters is what PQ would be. How we looking there? The diagram below shows a regular hexagon. If it's a regular hexagon, what does that mean, Nat? Regular hexagon means what?
All sides are equal, eh?
All sides alone are equal?
No, not all sides.
Yeah, all sides are equal, but that's not all.
Angles.
And then angles are equal.
Don't forget that. All the sides and all the angles are equal, right? So, the hexagon is LMNOPQ, whose side is 8 centimeters, right? So, if one side is 8 centimeters, that means what? One side is 8 centimeters, that means what?
All the sides are 8 centimeters.
Thank you. All the sides are 8 centimeters. And all the angles are equal. So, they want us to show that angle PQL is equal to 120. So, I can take the formula for the sum of all the angles in this hexagon. That will be n minus 2 multiplied by 180 divided by how many sides we have? How many angles we have, sorry?
6.
6. So the formula I put above there is simply the formula for the sum of all the angles in that hexagon. So this will be 6 minus 2 multiplied by 180 all over 6. Somebody work out that, please. So my answer would be 120 degrees. Put a box to indicate that it was shown.
Excuse me, sir.
Yeah, go ahead.
The video.
Right, so there you go. The vertices of a rectangle WXYZ touch the sides PQ, QL, MN, and NO of the hexagon in A part 1, right? The same hexagon above here we dealing with, right? So if it's the same hexagon, that means all the sides are equal, all the angles are equal, because it's a regular hexagon, right? They said ZY, Z to Y is parallel, well, ZY and WX are parallel to LM and PQ. So all these lines are parallel, right? And PO, sorry. Calculate the value of LWX. L to W to X will be this bad boy right here. How easy is that? Let me see who could figure out this.
180, so that
Right.
For you, the angle here will be 60.
60, but A, remember LM and WX are parallel. This LW here is a transversal, so the two angles within here will be 180. They add up to 180. How did I get here as 120? All the angles in a regular polygon will be the same. Alright? So that's how I got here to be 120. So I'm going to put this is equal to 120 minus 180 minus 120, which will give me 60 degrees, right? We know it's co-interior, but the question then asks us to write is co-interior. So guys, we have come to the end of Pythagoras' theorem, trigonometric ratios, and parallel line laws, right? 3 major topics. I am going to be sending this worksheet along with the video of all the classes, so people will not be looking here for part 1, looking here for part 2, looking here for part 3. No, everything will be in one. You're going to sit down, you're going to review these things and make sure that you're solid in them. Are we clear, my children?